All right, question number 3. This is one of those real world questions, or at least real world wannabe questions, where they're trying to show you a way that geometry might be used in life. And this is actually pretty good for a real world question. I apologize for the drawing. This is supposed to be a drawing of a river, and that's terrible artwork, but the math is excellent. And this is indeed how an engineer might measure the length of a river, or the width of a river. You know, he or she probably didn't want to go for a swim in the river, and so it was worth it to figure out a way to use triangles to do this, so that they didn't have to get all wet or figure out another way to get this measurement. So what we're going to do, I think the hardest part of this question is just unpacking all the data. So you have to be really organized when you see this word here, respectively. That means the first length mentioned, DE, matches the first number given, 3,000. And so let's immediately put that on the figure. DE is 3,000. You can put the feet if you want to. Continuing with that pattern of respectively, the EB would be your 1,200. That's going to go here. The BC would be your 1,000. And finally, the CE is your 1,500. That goes over here. And the question here is, what is the value of W? So we'll put a question mark by W so I remember what the final answer is supposed to be. And now what we're looking at, we've got to figure out W. We are definitely looking at similar triangles here. If you wanted to prove it, like your geometry teacher might want you to write a 2-column proof, you could do it. You would do it because, let's see, we've got a pair of vertical angles that are congruent. We have another pair of angles that were given to us as congruent. That tells me by the AA theorem that we have similar triangles. But please don't be proving anything on the SAT. Just know that when you have two triangles that kind of meet at a point here, you're going to have that similar triangle situation. So don't worry about AA theorem. Just trust that these are going to be similar. It means that the sides are in proportion. So the idea is we have to find two sides that correspond with each other, and that will give us the proportion. We need to find two sides where we know the value of both sides. And then we can just find the unknown value by using that same proportion. So the two sides that I see that correspond with each other are the 3,000 and the 1,500. And I know we have a little flipping action going on here, and I know that's happening because they gave us these two congruent angles. One was on the bottom and one was on the top. So when I set up my corresponding sides, I also wanted to use a bottom and a top. If they had given me a bottom angle and a bottom angle, then I would have compared the 3,000 to the 1,200 instead. But I can see here 3,000 corresponds to the 1,500. If you want, you can set up in a proportion like this. 3,000, 1,500 over 3,000 is going to equal my W. We're doing, is going to have the 1,000 on top. We're doing the smaller triangle on top and the bigger triangle on the bottom. If you want, you can absolutely use cross multiplication to figure this out. I don't even need to do that because I can look at those numbers, 3,000 and 1,500, and I know 3,000 is exactly double the 1,500. That means W will be exactly double the 1,000, so it'll be 2,000 as a final answer. If you feel better with the cross multiplication, you can do it, but I promise it will work out to be 2,000, and we will just bubble that in. Look a little like that.